Okay, so let me just share here the link where you can download the materials for today. So then it's going over a nice short presentation. Then we're gonna get very hands-on and explore the 51 models. I'm not sure if everyone here is on Discord already. If you're not, we have lots of materials always running up at this kind of initiatives, so do join. Yeah, I think I'm gonna pass it to you then. I'm gonna be here. I'm gonna follow the tutorial along, and I'm going to catch up on the chat and make some questions as we go. And as more people join, we are just going to follow up with them. Anyway, we are going to record, so let's see in case we can share as well afterwards. Great.
Awesome. So I'm gonna do some fast rapid fire slides here to explain who I am, what 51 is, and then we'll get into the code. I'll also be stopping at some points to clear out some chats. If you ever have any questions about what you're seeing, or maybe you want me to expand a little bit more on something I touched on, because I'm not going to be able to go into in-depth on every single feature of 51. So more than happy to answer your chats, as well as you can always ping me after and things like that. Without further ado, I'll get started. So thank you everyone for coming to the 51 Code with Me 51 workshop. Maybe it's your first time getting started with 51, or you're looking for a more in-depth understanding, and that's totally cool, right? I'm excited to bring you what I have to offer today. So getting started, right? We keep on seeing, we were just chatting about it, that the villain of ML is more clear than ever is just bad data, right? More than ever, you'll see that you're going to train your model, you'll get great results. That model will be, outdated in a year. You're going to train a new model, but what's not going to change is the data that you trained it on, right? That's going to stay the same unless you've cleaned it or added more data and so on. And so we start to see these issues arise, whether it's model bias issues because you haven't addressed all the gaps in your data set, or actually now we're heading towards deployments, and we're actually seeing cases of lethal actual physical danger, whether it's autonomous vehicles or warehouses or machinery. It's no shock that bad data can lead to some really bad situations. And overall, the idea is that poor quality data will just reduce the performance of your models, straight up. However, the task of creating these better data sets can kind of feel daunting, and like you're never going to get anywhere, no matter what augmentations you've tried or what you've tried to do to your data sets. It's such a pain to wrangle it all up and actually get there. But thankfully with 51, you get empowered to feel better. We offer a range of different tools for you to use in your computer vision workflows to level up whatever your data sets are and where they are today to the next level. So we're going to go over a couple things, but I can show you a couple teasers about what you can 51. So obviously you can visualize your samples in 51. But we can actually do things like select images and then sort by similar images to find the most similar images. We can also then sort on our data by doing things like text similarity. So you can just prompt your data, say something like animals, find the most similar samples, and then load it up like that. And then if you ever feel like you're stuck in your 51 journey, you don't know where to go, we do offer Voxel GPT, a bot that can help you answer your questions, give you code that helps you get to the point that you're trying to get to, as well as links to the code of where it's found within our documentation. It's not perfect, but it absolutely is a great starting point for help you get to some basics within 51, or if you're just looking for a refresher and don't feel like diving through the docs. So we'll be going over a couple things. We're kind of running through some housekeeping right now, but we'll go over an overview of 51, some installation environments, basic concepts, and then a hand-on exploration. Like I said, I'm going to rapid fire through a couple of these. So if you ever have any questions or want me to expand, just put it into the chat. So what is Voxel 51? Voxel 51 are the lead maintainers of the open source 51 toolset. I'm a Voxel 51 machine learning engineer. My name's Dan Garau. I'm also the developer evangelist at Voxel 51. What exactly is a voxel? A voxel is a pixel to what a image is, or video is to an image. So it's the volume element now within a video. And then what does 51 stand for? Why did we call it 51? It is a poorly kept secret, I'll say. But if you have any guesses, feel free to shoot them in the chat, and I'll tell you if someone says it right. I'm not going to tell you if you get it wrong. So moving forward, what is 51? 51 is a dataset curation tool. In a nutshell, you can visualize, clean, curate, find the hidden structures within your data, evaluate your models, and have a fully customizable and connected tool set that allows you to explore your data like never before. You can find, filter, match, sort, and select your data sets by using a variety of different filters, sliding bars, or whatever you need to get to where you're looking for in your data. This could be filtering or matching things like labels, but also things like confidences, size of bounding boxes, and more. It's really up to your imagination. We can also remove duplicates and spurious labels. So using built-in functionality within the FiftyOne tool, we can find likely duplicates in your data set, where then you can then tag them to remove or go back to annotation, as well as find some spurious labels. That might be cats that you labeled dogs that we're pretty sure are cats, or it could be things like overlapping bounding boxes, where 2 bounding boxes are covering 1 person, and we only really need 1. Using all these built-in functionality, it's super easy to find these samples and remove them or clean them up in your data set. You can also tag, add metadata, and add predictions to your data set to make them more powerful and give you more insight onto not only what your data set is, but how your models are performing on them. Tags and metadata are super powerful because it allows you to add more information for some things that just make sense to add to your data. If you want to label things like where they came from, if they come from one city versus another city, that doesn't normally fit into something like a bounding box image detection label data set. But using tags or metadata, you can quickly add these in so you can sort and search your data set to find what you're looking for. We can also add predictions to create these overlapping bounding boxes on our ground truths, where we can compare and contrast where the ground truth is and how our models are predicting. We can also fix our annotation mistakes. You can find them various ways, either using built-in tools, looking through yourself, or doing something like high confidence false positives, where your model is very confident that something is there, but it maybe isn't labeled. We can then use one of our open source integrations, such as CVAT, Labelbox, or Label Studio, where you can then just plug into these these annotation tools, annotate as you would normally there, and they load right back into your FiftyOne dataset with little trouble. Finally, the whole point of FiftyOne is to get you the highest quality dataset, find that highest subset for whatever your task is, and then create a view. Views are ways for you to save certain subsets or slices of your data sets to FiftyOne so you can come back later. You can also export these to any data formats, whether it's like Cocoa or Voc or whatever format you're looking for, to then train on afterwards. This is super useful whenever you're trying to do things like remove a class from your data set, train on a single class, or maybe only another subset as you define. We also offer many other core capabilities as we'll fire through here, things like aggregate statistics, which can't be underestimated whenever it comes to data set and computer vision tasks. This allows you to get understanding about how your classes are laid out, how your model is predicting in terms of confidence, and more. We also offer embeddings and different ways to visualize and explore embedding spaces. Here we can see that we can actually visualize our embeddings, lasso select different samples, and see how models, whether it's like a clip model or a foundation model, are visualizing our data. Once again, everything that you're going to see here today is highly interactive and plugs in and is connected with FiftyOne. So either if you're running in a Jupyter notebook or within the app, you can use these interactive components to explore your data set. This goes across multiple different points, where in this case, we can do something even like geospatial, where we can lasso select Manhattan from New York City and get all of our samples from there. We also include all different core evaluation tools, such as your classic one-number metrics like precision, map, and true positive stuff. But you can also explore different things like confusion matrix and different curves. And this can be done at different levels, whether you're doing it over your entire data set, you're doing things over a sample or a label level. We allow you to cut and slice through evaluation metrics as much as you want. So if you want to do over your whole data set, or if you only want to do on dogs or small bounding boxes, these are problems that we can easily define within FiftyOne to get these results. So here you can see something like a confusion matrix in Jupyter Notebook, where we can then click and then live see which samples we're predicting correctly and look at our misclassifications as well. FiftyOne is super agnostic when it comes to importing your data sets. This means that you can bring in your data in any different form, whether it's one of the popular forms that we already support. I think we have over 25 different formats that we support inherently. Or if you're bringing in your own custom data point, it's still very easy wherever you can bring in your data sets, bring in your labels, wherever they come from, and load them in. You can also apply your own models. We typically stayed with PyTorch, TensorFlow, or sklearn models, but you can bring in your models from wherever and apply them to your data set to load predictions or whatever you're trying to do with your data set. Different media types are supported within 51, such as image, point cloud, geospatial, video, DICOM, and groups data. And we also support different labels such as detection, masks, key points, classifications, action recognitions, relationships, and more. And all this is going to be very highly customizable. Whatever you want the app to look like, however you want your data to be presented to you is definitely possible within 51. Here we're looking at an example of a groups data set where these sensors, whether they're a camera or a LiDAR sensor, are placed on a car and are firing at the same time, at the same timestamp. It only makes sense to then group your data so that each timestamp has the left camera, the right camera, and the LiDAR sensor at the same point. This way you can construct more powerful data sets where data that is inherently grouped should be together at all times because they happened at the same time can be presented to you this way. And it also makes it easier when it comes time to unfold your data set in terms of an application or a training use case to grab these data points based on their similarities. And it's no longer diving through files or wrangling through ever Python code in order to organize your data as this. Lastly, you can always add plugins or ask Voxel GPT to customize however you want to get to. So if you're trying to verbalize how to look for something in your data and you don't know how to do it within the code, feel free to talk to your data using Voxel GPT to get exactly what you want. So where 51 fits, we sit right between your data and your models. Data, it can come from anywhere. It could be from the cloud. It can be local on your computer. It could be in whatever format. It could be of media types within computer vision. And then you can use whatever models you want. What 51 aims to do is sit in between and give you that highest quality data set, clean up your data. That way you can get to the final point where your data is going to be able to train your model to the highest ability. This doesn't mean that we sit in an awkward spot. We are highly connected with all your popular tools around it, whether you're using data sets from certain places, popular annotation tools, notebooks, clouds, ML frameworks, experiment tracking, or models. We happily plug in with all these environments. There are three main pillars to 51, as I'll go over into our code coming up soon. One is the 51 library, often referred to as just 51. This is our core SDK and Python library. There's the 51 app, which is the visualization component, and then the 51 brain, which is our ML framework, drives embeddings, and similarity index component. We also have 51 teams, and if it's something you're interested in, more than happy to chat after this. This is our enterprise version, which allows you to work with different team members, do things like data set management, data set versioning, data set permissions, use things like collaboration tools, as well as delegate operators and much more. Basically, it's the best way to work on data sets within a team, and more than happy to talk about this afterwards. Feel free to ping me. So in order to install 51, pretty straightforward. I bet everyone here has been pretty familiar with something like this. We recommend you use a virtual environment, and we currently support Python's versions 3.7 through 3.10. In order to use a virtual environment, you can either use a classic virtual environment or Conda. I'm currently a fan of Conda. Create that environment. It's just super easy. 51's not picky when it comes to what packages it needs, but often training things and GitHub repos are. So it's nice to not block into these issues. We also offer 51 with a desktop app. If you like launching the app from a desktop app for whatever reason, more than happily, we have a supported version with that. Just have to add desktop to your pip install. Once you're installed, you can just check to make sure that everything is installed correctly by importing 51 and printing. Extras, not needed, but also helpful whenever you're using pip 51 is we do support things like Jupyter Notebook. And if you're going to be using models, things like Torch Vision, TensorFlow, and then domain specific, if you're using video data sets, if you're using point cloud data sets, we recommend that you download FFmpeg and Open3D, as these are driving the backends for our tool. Now, just to cover very quickly some basic concepts before we get into the code. For years, we've seen computer vision or just any data and AI be stored in tables. We see in 51 that this does not work out to as well as you would hope, where on our image on the left, we have our bear. Our bear has a single detection. On our image on our right, we obviously have lots of detections, and this doesn't naturally fit into a table. In order to overcome this problem, we start to lean towards unstructured data, where we don't want to have to be wasting these columns on a bear with a single detection. Or another way to look at, we don't want to be storing the same data on the left like we store the data on the right. So this leads us to creating unstructured data. So in FiftyOne, we have multiple different levels and we can step through it very easily. The data set is our overarching holding object. It's going to hold all of your different objects, samples, images, whatever term you want to use. And it's the parent class within FiftyOne. After that, we have our samples. Samples make up the different images within our data set. They can hold information like metadata and labels and all the different information you want to store within your data set in order to gain insights on the image you're trying to study. After that, we have fields within our samples. This is the stuff that's going to be holding tags, your file path to your image, your labels, and any other computations you make on your image. And this ends up looking like something like this at the end. We have a data set that's encompassing all of our samples. And then within our samples, we have our metadata, our ID, file path, any tags I mentioned before, and then your predictions, whether it's ground truth or just a normal model prediction. And when we talk about what exactly can you add to your samples, how can we empower our data sets, we try to be as Python-like as we can, where you can add anything like a list or a dictionary often, obviously, as this is very commonly used with things like detections and such, but you're also able to add any of these other variables such as bools or ints or floats, strings, especially very powerful, where you can then query these at any point, get the information, and level up your data sets by adding more metadata. Likewise, we offer a bunch of different label types, and the only difference between a normal field, such as adding a string, versus a label field, is the label field will always be tied with the visualization of FiftyOne. So anytime I add a classification, I'm able to see that in the app using some leveled up version other than just saying what label it is. This goes for all of our different labels. Nice thing about FiftyOne is a lot of times when it comes to samples or detections or labels, whatever it might be, it's very agnostic to whatever media type or task. It's just going to become inferred based on what is passed into it. So you don't have to worry about passing in a JPEG versus an MP4 or passing in a bounding box versus a mask, where both of those are going to be available within the same objects. So I know that was a little bit of a rapid fire through our slides. I want to get to the code. I know that's what we're excited for. It's code with me, not watch PowerPoints with me. So if there's doesn't seem to be any questions in the chat, so I'll just go on to the next session.
I have one. So
perfect, yeah.
Rather than picturing like your data set as a set of images, you have these concepts where you have a sample, and so a specific image can have thousands of samples, and whether one can just have one sample because it's just something, one object that was recognized in there, and you somehow, is that okay? Is that right so far?
So it's pretty close, right? A sample is going to be your like atomic component to your data set. So if you're going to drive your data set by saying a sample is an image, then like every sample has a file path, right? That's a good rule to follow, right? Each sample is pointing to something. Now you do run into scenarios with like a video, where obviously a video is made up of multiple different images, right? So your sample in this case is the video, but you can still access frames, right? And then you just step another level down. Likewise, when we look at things like grouped data, if I have a group data where I have a left camera on my car and a right camera on my car and a back camera on my car, one sample would be the 3 pictures together, right? And then you can then go from there and step in.
Okay, and everything is seamless, like for the user. So the metadata, all that is
super easy. We're gonna get into it, and it's like it's as easy as just saying equal and then dropping whatever you want to add to your sample, right?
Okay.
It's just about empowering your data set of being more than a label and an image, right? We want to be more than that. So what can I add to my images or my samples in this case to level them up?
Yeah.
So this Jupyter notebook.
So you have one more question? Like, can you see the chat?
Yeah, I'll look through right now.
Yeah. How could I represent annotations like 3D segmentations for medical imaging data and tracks on temporal video data?
Great question. So we support both of those. In terms of 3D segmentations, Currently today, we support like semantic LiDAR point segmentation. So if you have a point cloud, you can then label each one of your points a specific class. We don't currently support things like meshes or 3D objects, but it's coming soon in one of our next releases. In terms of tracked bounding boxes, like index or multiple positions of the same object over time, absolutely, right? Video data sets, that's imperative within them. And we have many different examples on how you can get started with tracking data sets. I'm actually putting out a blog maybe sometime next week on exactly how you can do that.
Yeah, share it with us for sure.
Absolutely.
Okay, no more further ado. Let's get into
Yes, no problem. And if you have any more, just pile them in. We can take breaks and address them. So we have this notebook. A lot of it is about how to get started, how to install, things like that. We're going to be skipping over a lot of that. We mentioned it before, but if you ever need a refresher, it's all here for you. So no better way to start than a trip to the zoo. Everyone loves the zoo. I hope. Maybe, you can like the zoo however much you want, but we have a model zoo and a data set zoo. And I can tell you I like both of those very much. So within both of these, pretty straightforward. We can start by importing. We always use the alias FO for 51. And then when we add another part, such as the zoo, we're just going to add the letter. This is standard convention across 51. So we can look at our zoo data sets here. We have a bunch of different zoo data sets, some big ones here like BDD 100 or Coco. We also have things like Kitty. And then we also offer a bunch of different quick starts based on whatever task you want. So quick start is the normal basic detection one, but we have some quick start examples for geospatial, quick start for groups, like that's the car data I was explaining before, as well as quick start video. That would be your quick start for things like a tracking video data set, as you mentioned, as we were talking about before. We can also sort these data sets based on their tags. So if I'm only looking for detection data sets to practice with, we can sort by their tag like that. We also offer a list of models to get started with. So some classic ones like AlexNet, but then some more advanced ones like Clip, and a lot more, both for TensorFlow and Torch, depending on what you prefer on using. So to get started, it's easy. We could just load zoo model or load zoo data set. We're going to load the quick start. It's the most basic data set here. It's a good way to get started. Now we can always print our data set here to get some information about it. So here I can see the name of my data set. I can see what type of data set here is an image data set. I can see how many samples it is. So this is 200 images within my data set. Persistent means that it's saved to my disk. Any changes I make to my data set are going to be saved to my disk. And then we have a bunch of other fields here, some things that I preloaded here to save some time in the future. But we can add, we can see that someone's added ground truths. We have predictions. Someone has computed a uniqueness score on this data set, as well as we can see someone has done an evaluation on this data set. This is a good way to tell if you're ever loading your data sets in, exactly which data set am I looking at. You can remember based on this information, or how far did I get along. I can see I've already done an evaluation against my predictions. To load a model is pretty simple. We just have to call load zoo model, and then you can print it out like this. If you want to evaluate your data set, as I've already done here, you can just call evaluate detections, whatever one you're going to compare against, in this case, predictions, and then pass an eval key. This way you can come back to it. And it's just as simple as that. We can get our first evaluation in. So the part that everyone's excited for, we can launch our data set here. Using the 51 launch app, this is going to launch the visualization component. You can see here that it does launch in our notebook, but I will be kicking it over to our browser as it also runs here. Using the browser is nice as it's much bigger and you can look through it. So lots to break down here. We're going to step by step here. So let me start by saying that you can switch your data sets on the top left. We're working with our quick start data set here. So we're going to go here first. First and foremost, looking through your data set, right? How many computer vision engineers that I could tell you that I've met that just don't look at their images before training their models? So being able to scroll, you'll be met with more images on this infinite scroll. We can click on a sample and start to look more into it. So here we can see a couple things. There's a bunch of stuff going on the right, as well as these bounding boxes. So we have ground truth bounding boxes here, shown in green. If I hover over a box, I can see the label, the area, whether it was correctly evaluated, and much more. As well as I do my predictions, we can turn on and off to be whatever visual clarity we need. So I can see by looking at my predictions, we did miss this bird on the right. Now, if I pull up my ground truth, I can tell that's the case. Now, as we start to go down this bar on the right, we can see what our data is tagged is. We can see it's tagged as validation. And we could always add more tags if we want, such as this. I can either add it to a label or I can add it to a sample. And I could say something like, this is a bird image, or I like this one, right? Whatever I want to tag my image, and I could always come back to that and save it. We also have some metadata that's been computed, which is useful for things, especially like width and height of your image. If you're going to train a model that only accepts certain inputs, whatever, or you're trying to remove maybe poor aspect ratio, this is a great way to start. So we get down to our labels, we can see a bunch of information here. We can see our ground truths that were correctly predicted, as well as falsely predicted. We can also see what labels we have. So we only have birds in this case. But if we go to our predictions, we can start doing things like seeing the confidence levels of our different predictions. We can also see which ones were wrong and which ones correct. And we can also see the different labels that were predicted on our data set here, or on this sample here. So we could see that even though it got bird, it did have some wrong guesses, such as elephant, sheep, and bear. Taking a step back, we can take a breather and start to look at a whole data set level. So I'm going to tab these down to just, we'll go one by one, not overload anyone. So just as I was talking about before, we can look at our ground truths. We can look either sort by their evaluation, or we can sort by label. So if I want to see only samples with people in it, I can easily just set that up. Likewise, I can go into my predictions and do the same thing. Another handy way to do this is I can go into my predictions and show only high confidence scores, such as this one. But then I can do some really interesting views where now I can show high confidence scores that were false positives. So if I go into my image here, you can see that I have some unlabeled stuff going on up here that my model's picking up on. As well as if I go here, I can see that some of the bounding boxes on my ground truth, I can turn off my predictions, are just poor on this broccoli. You see we're not covering the entire broccoli here. My model's pretty confident that it's getting the entire broccoli, but maybe this is an annotation cleanup that needs to get done. So using this, we're able to find very interesting views very quickly within our data set. So just like that, I found some annotation mistakes. So let me just clean up all my views here so we can go back to our starting point. So there's a lot you can do with just sliding around, getting different filters. If I needed to remove a class from my data set, I can easily just grab all the ones that I want. I can also use different views up here, where if I want to exclude by certain classes, that's also very easy. We also have a bunch of different views, which we'll go into later. Metadata, this is what we were talking about before, where I can sort and search by different things. So if I want to see my smallest width, these are obviously all vertical images. And now this might be something that I want to be removing from my data set as well, is that there's probably no way, good way I'll say, that this kind of vertical image is going to go into a model and perform well after it's going to be crunched up by some pre-processing. Something to consider in our data set. We can also look at our tags here, where I have sample level tags, such as my validation image, show all these images, but I can have label level tags. So if I click here, I've gone in here before, and I can see, similar as we saw before, I have predictions here. Now let me clear this off because I'm hiding it, but we can see that we're missing a cup here. This is a mistake because our model catches the cup and it doesn't get it. So we can find and label our mistakes such as this as well. We can go up here to our panels. The aggregate statistics I was talking about before, we can pull up. So we can see things like our labels. So if we want to do ground tech, we can see our different label distribution. We can also compare that to how our model predicted. Obviously, these should be the same, but it's going to change. We can also sort by the confidence of our predictions to see how confident we are on average predicting our data set, and much more. And the last thing I want to show you is our embeddings. So I can go into my embedding space here. I've pre-computed these embeddings, and I will mention how to earlier or later on. But now using a clip model, if you're not familiar with Clip, it is a very great embedding model in order to get insights on how your data set is grouped. And now I can start lasso selecting my model or my data set and bringing up like images. So here we see all these different food. So all of our food is combined here. Let me just turn off my labels so it's a little bit more evident, a little bit more clear. So we can see all of our food here. If I go down here, this is going to be another set of group samples. So these are our cats. And you can even color these by uniqueness to see which are your most unique, or other things if you're interested, to get more understanding about how your data set is laid out. So I'm going to take a step back here. Go back to our code. So you also never have to jump into your browser. You can always use this. This is going to work exactly the same way as we looked at before. It's all the same functionality. So just close this out.
You have a question here. Someone's asking if you can have multiple predictions from different models.
Absolutely, right? We can overlap our different model predictions and then compare and contrast how our model is performing and use different ways to slice and sort our data set to see where each model is performing the best or maybe the worst.
How about the embeddings? Can you extract them? Imagine that you want to get those embeddings and do some like visualization with them. Can you extract those 2D, 3D data points? Can you do that?
Yep. So that's definitely available with us. You can compute your embeddings and then grab the embeddings if you're going to pull them to somewhere else. We also support using vector database backends for embeddings. So instead of using what we provide today, which is sklearn, I believe, you can compute like indexes using things with one of our integrations with like Pinecone, Quadrant, Milvus, and like LanceDB. So you can use the embeddings to get into all the fun things in embedding space over there. It's really just, we can hand them to you and you can take them and do what you want.
Okay.
So as we go into how do we add things to our data set, how is our data set laid out, we can start to get into different components here. So we can easily compute our metadata by just calling compute metadata. This will be able to give us all of our height, width, size of our image. Just nice to have handy stuff when it comes down to the line of inferencing or removing some stuff from our library or our data set. So as I mentioned, you can inspect the data set. You can get exactly an understanding of what fields are inside, what currently is being held within our data set. Now, if you ever want to look at a name, we're going to start to get into this convention here. Whenever you're accessing different parts of FiftyOne objects, we're going to use this dot notation or dot syntax to always access it. So as we see up here, we have our dot name, quick start. When I call dataset.name, I get quick start. Likewise, I could do, persistent, and I would get persistent. And we're going to see that. And if you ever want to change anything, it's as simple as saying dataset.name equals, and then passing what you want to pass. So here I can change my dataset name from quick start to my name, and we can see that my dataset has been transformed here to my name. And likewise, we can get to media type and tags and persistent, as I mentioned. So if we see it up here, media type, we just pass it down here, and that's how we can get it. Same thing with tags, and same thing with persistent. In order to grab a sample, we're going to grab just our first sample here, just to get an understanding. So a sample works very similar to a data set in terms of how you can access it. So here we can see a unique ID that FiftyOne has passed to our sample. We have a media type to know what type it is, the file path to where it's located on my computer, any tags associated with it, any metadata associated with it, and then we get into our predictions. So we can see a way predictions work in FiftyOne, we usually hold stuff within lists. So here we have a detections list. You can see it starts here. And then within our list, we hold all the different detections for our ground truth. So we have our first bird, and we have a second bird, and we have a third bird. Notice that we have some things that we could add. We could add a mask if we had an object segmentation. We could add confidence if it was a prediction. We could add an index if it was a tracking data set, and so on and so forth. But not needed for every case. And then we have our predictions that come afterwards. And I won't go into this as we have a lot of predictions on our data set. But you can get all this information by just printing out your sample, and it will pass you all the information that your sample holds. Now we can see that if we want to get a detection, we're going to do the dot syntax as we were doing before. So we do sample dot prediction dot detections, and this can print out our first detection from our model. We can see it's our bird. And if I wanted to get the second one, I could print one. And if I wanted to get all of them, I could print all of them, right? Just like that. So we also try to include a bunch of Python things in our library. I mentioned that before. There's really no better way to describe it other than you're still able to do things like indexing. Here we're grabbing our first 10, and then I can call things like distinct to get all my distinct labels within my first 10 samples. And we can see all the different labels within our first 10 samples here. So I'm just going to import some libraries, and I'll bring this up later. So we talked about tags. If you ever want to apply tags to your data set, as simple as get the tags list, right? So if we take this off, we can see my tags list. We have no tags right now. If I want to append tags, I can do that. And then when I go back to my tags, we can see I've added my tag to my data set. And this is for our entire data set, not just one sample. In terms of also Python stuff, right? We can still count our data set or do the length of our data set. You can still enumerate your data set, right? So you can start saying things like for sample in my data set in order to get each sample in order, and all these different other ways that you would normally access objects in Python. That includes aggregate statistics. Here we're doing a mean uniqueness, so we can get the average unique score of our data set. And like I said before, we can just get all the different labels in our data set by using distinct as well. So now we're going to take it a little bit further. We're going to start creating views and slicing up our data set a little bit more. So we can use limit to grab 10. So if I want to look at only a specific subset of my data set and visualize that within my app, I can set the view of my app. I don't have to launch it again to whatever I want. In this case, just 10 images. And we can see that we get the first 10 images of my data set. We can look and see that it's the same sample from before. We still have our birds here, so it's all still the same. Likewise, we're still doing all of the same syntax here. So if you ever want to get the file path, the tags, or the ID, you can grab that just the same before. Moving forward, if you're just trying to get detection labels, once again, just hammering home the point of just this dot notation to grab all the fields or objects that you're interested in. So there's a couple ways you can grab samples from your data set. One we talked about before was limit. Skip is the opposite. Right now we're skipping through our data set. We're going to skip the first 10 to get the 10th image, and that would work the same. Or you can just grab by either its unique ID or its file path in order to grab these samples as well. However, we know that we want to create more sophisticated views in our data sets. We want to be able to slice, sort, filter through our data set to get exactly what we want out of it. So we offer a bunch of different view stages that allow you to get there. View stages are all the different ways you can slice and sort through your data set in FiftyOne. There's a bunch of different ones, such as exclude, filter, group, match, select. And we even have some transformation ones, such as two patches, which will allow you to get all your object detections patches and create a view off that, or two frames, which is going to get your video data set to each frame within the video data set. So we're going to look at some simple examples here. So if I want to grab the first 20 samples of my data set, I can call the limit 20 as I mentioned before, or we can just do a classic index. We get the first 20 as well, both work. And we see the same syntax follow here when it comes 50 to 150. We can also get a random sample here by just calling take. So take versus limit. Take is random and limit is not random. And we can also call data.shuffle to always shuffle up our data set. Super useful for things like train, val, test, splits for shuffling your data set up. And of course, you can pass things like seeds to reproduce. We can also sort our data set by a specific value. So we have a value you can compute in 51 called uniqueness. Uniqueness shows you your most unique samples or your least unique samples. So we can call sort by. And now we're going to introduce this new idea here called the view fields. So as we saw before, samples contain multiple fields. Fields could be things like a uniqueness score. It could be your detections. It could be a tag you passed on it, right? Anything that your sample is holding. And we are obviously going to be filtering, slicing, and sorting on those fields in order to get our information or whatever our subset of data set is. A view field is what it sounds like. It is a field created in order to get a view. And what I mean by that is if I want to grab and sort my data set based on the number of detections within each image here, so we have ground truth detections length. So if I want to sort, so I have the most detections in my image, my most busy crowded images on the top, and then I want my least ones, the ones with the least detections on the bottom, I'm going to have to sort based on the length of my number of detections. However, this value here, where an intrinsic int that represents the length of my, or the number of detections in my images doesn't exist in my data set, right? I haven't populated this in a field yet. So what I can do is I can use a view field as I imported here to basically pseudo create a field that is a int that just holds the number of detections in it. This isn't going to actually be added to our data set. It's only going to be used to then sort by it. And then it is removed from our data set, right? So I can then generate more powerful sorting methods by not necessarily things that are in my data set, but things I can, pass either an expression or a value in order to then create my way to sort through my data set. Another way to explain this is if I want to find either a cat or a dog in my data set, I can use this match. And normally I could just match a label. However, I want to match multiple labels here, either a cat or a dog. So I'm basically making a new view field here that is a Boolean where it is true if it does contain a cat or a dog, and false if it doesn't contain a cat or dog. And then we match our truths and then get rid of the falses, right? Another way to look at this view field. Likewise, if I want to show only predictions with confidence over greater than 90 or 9.5, I can create another view field that's going to resolve to a Boolean where I'm filtering my labels. I'm going to pick predictions to look through, and then only my predictions that it's true if the confidence is over 95. Same thing here. If I want to do only ground truth detections that have labeled dog, I can filter my labels and only true if this, right? Only show me the samples where my label is equal to dog. Can I change filter labels? Absolutely. You can stack as many of these view stages on top of each other to get to exactly the nitty gritty you want, right? So if I wanted to do something like cat or dogs that have a confidence of over 95, I would be able to do something like this, right? And this would just stack on top of each other. So now I have cats or dogs that are over 95 confidence. Thank you for coming, Michael. So now we're going to talk about how you can modify your data, how you can add these samples detections to your data sets, especially handy whenever you start to add model predictions to your data set. So we can clone our data set. If you ever want to do a scrap work, you can always clone it, make a subset, get 100. And to delete samples, very simple. We just call it delete samples and pass in the samples you want to delete. So we can easily delete these samples, and then we can see that we've gone from 100 to 95. We can also add samples using either add sample for one sample or add samples for multiple samples. And it works the same way where you just have to pass in a 51 sample or a list of 51 samples. And these will both work here where we go from 96 and then we add 10 more and we add 106. So in order to add and remove samples, just call add samples or delete samples. If you're trying to build a data set from scratch, you can do this by passing a sample and just a file path. This is your most basic sample, has nothing else attached to it, no labels, nothing like that. But we can just pass this path to an image, wherever it might be on your computer, and that's your new sample. And then we can then add this sample to our data set. Likewise, you can create a new data set. All you need is a name, and then you can start adding your samples into it. And then all of a sudden, you're starting to build your first data set. naturally what comes after that is how do I update my values in my sample? I want to add these things like labels. I want to add these Booleans, these ints, these strings, or whatever it might be to my data set. Well, in order to do so, we can just grab a sample here, pick a value that you're interested in changing. Here, I'm going to change uniqueness to 0. It's an int value, or sorry, a float value. And then we save. Anytime you alter a sample, we save it. So here I can see that I've changed my uniqueness to 0. If you ever want to create a new field, we can call add sample field. So I want to create a field called number of ground truth detections. Before I was talking about view fields as these things aren't actually in your data set, right? We're only creating them to create a view. Here now I can then add a sample field and then populate a field across my entire data set using view fields as we did before. So before we were only using them to create a view. Now I can use the same logic to populate all my samples with a new field called number of detections, essentially, and then use this expression that will resolve into what I want to add to each specific example, right? So for each specific example, it will count the number of detections and then add that to a new field. In order to add detections, it's as simple as defining whatever you want your detection to be, such as this is a detection that YOLOv5 generated. I'm going to call it YOLOv5, and then passing in a 51 detections with a list of each detection. I'm going to scroll down to this part as it's important. So here's a classification example. I can grab my first sample, or you can do something like, if I'm doing this for each sample in my data set, I could say for sample in data set, and then go from there and do this for each one. So all you have to do, this doesn't have to be created beforehand. It could be whatever you want. So you can make this right on the fly and then just pass in the label type that you're interested in here. In this case, it's classification. All you need to pass in is the appropriate label. And now all of a sudden my data set is populated with classification labels, right? Or in this case, only on one sample. If you want to do this for a detection, a detection example would be a new detection. This is just the box. We use 51 detections. In order to do a bounding box, you just need the label, and we use normalized bounding boxes. You can then append this to a detections list. And then once we have all of our detections within our image ready, we can just add it. Like I said, this doesn't have to be created beforehand. It can be brand new, 51 detections, and then just pass your list of different detections. Save your sample, and then you'll be able to have your new bounding box within your sample. Last couple things I'm going to harp on here. I want to open up for questions at the end. Evaluating, we mentioned before, evaluate detections is super easy. You can print out a report to get very specific insights to your data on how your model performed on each different class. So I can start to see things like bicycles, not so good, birds, pretty good, right? And understand exactly how we're performing on each class. But I can also do evaluations on views. So let's say I created a view called like small bounding box view, right? Where I've only set bounding boxes, like I'm only going to evaluate bounding boxes that take up less than 30% of my image or something like that, right? These might be people that are very far away. It could be very small objects in my data set. I want to see how my model performs specifically on small bounding boxes. You could pass this view into evaluate detections and get the same kind of report for whatever set or subset of your data set you're providing. We can then, of course, do a bunch of things as I showed before, where you can now sort and slice based on your evaluation metrics, such as your false positives, showing your highest confidence false positive or annotation mistakes, plot confusion matrix. You can do evaluation curves, everything you're interested in. Lastly, two more things I'm going to get to, and then we can start to go into questions. More than happy to open up some code and just show you how you would do a pseudocode. Once you're all done, you found your views that you're interested in. This is your perfect subset that you're interested in. You can save your view. You can then export your view to things like Coco or Boke or whatever data set format you're interested in, whatever maybe your model is going to train on to get to the next step. Lastly, the only other thing we haven't touched on yet is embeddings and how to do them in FiftyOne. It's super easy. If you're interested in similarity embeddings, all you need to do is import the 51 brain, compute similarity, pick a model. I use clip here due to its textual embedding ability, and then pass a brain key. This will allow you to do similarity searches in your data set. And then we can do compute visualization. Once again, pass in your model, brain key, and your data set. And this will allow you to show that embedding space where we're circling and getting all the information of our data set. I'll pause there. I know I went through a bunch, and I'm very excited to get some Q&A in, so we can start there. Let me open up my local host again, pull up my view. All right, so I'm going to go to the chat. Chitra seems, is detection associated to a model? Can I trace back which model produced detection, especially because I want to store detections from multiple models? Great question. So in order to do what you're achieving, let me go to the part that we were talking about before. So in this case, right, I'm going to imagine we have a data set, and I'm going to say for sample in data set, right? And we're going to assume that we already have ground truths in our data set. I would say something like detections equal to YOLO v5, detections. Now, this is not a real string. Just put your YOLO v5 detections in here, right? We need a label and a bounding box for each one, right? Likewise, I can do detections 2. And this is my, faster RCNN, right? And these have labels and bounding boxes as well. Once we have these ready, I can do something like for detection in detections, I start grabbing this code here, right? Where I'm doing this. Oops, sorry, I wanted to make a new line. So I'm doing this where for each detection that YOLO v5 has provided to me, I'm grabbing the code, I'm grabbing the bounding box, I'm putting in the appropriate label that is told me, right? So it's detection dot label or something like that, right? And this one's going to be my detection dot bounding box, and above here I've done my bounding box conversion, whatever this might look like, right? If it's coming from a different format, right? I know this is a little bit long-winded, but I want to give you the full view. So bounding box conversion here. I've now appended my detection. Now det has all my detections that I'm interested in for detection. I can then do sample YOLO v5. This is my YOLO v5 detections is equal to det, right? Now it's all good. We can grab this. And we've now populated a YOLO v5 detection. Now every sample, is going to be updated with a new YOLO v5 sample. Now I can do this same code block here, like this, but this one is detections 2, and it will be a faster RCNN instead, right? Like this. And now my field will not have only ground truths, but I'll have bounding boxes for YOLO v5, which will be one color in my app, and I'll have one for faster RCNN. So if I go to my app here, where we see labels, see where we see ground truth and predictions, we would imagine ground truth, YOLO v5, and then another one that says like faster RCNN, right? And then we can compare and contrast and show different things like highlighting the boxes and such to get the visualization we're looking for. Can I extend?
Thank you so much for being so patient.
Of course, yeah. And if you ever have more questions after this, I'm on LinkedIn, Daniel Grau on LinkedIn. We have a community Slack on FiftyOne as well. I'm sure Jimmy has passed the different links in the chat. Totally open to asking and answering more questions there for sure. So Marius, can I extend the table of metrics with my own metrics? So you can add any of your own metrics that you want to any sample. They can be a 51 label if it's a label that you're interested in adding. If it's not a label that you're interested in adding, it just has to be one of these, right? Like it just has to be a Python object. And and this Python object can come in many different forms. So depending on how you want to represent your data, you're more than free to add this to your samples, right? So if you have some float value, maybe it's like the speed of the car, right? Velocity. You can add velocity to each field, for each sample, a field that's velocity, that has the appropriate velocity. I hope that answers your question. If not, I'm happy to expand.
Yeah, maybe elaborate more on that. I mean, on the table where you showed that we can calculate recall precision, for example, can we also extend this with other metrics that can be calculated there?
Yes, so you're able to access all those metrics. So if you're going to pull them in to create a new metric, for instance, definitely. If you're trying to alter the config, like for things like map and IOU, I want to lower or raise my thresholds because I'm lowering them because I'm publishing a paper and I want my accuracy to be super high, or I'm raising them because I'm deploying this and this model actually has to work outside in the real life. We have different configs you can change, right? And super easy. I'm just going to go to you can just Google it, evaluating my models. And we have here all the different ways you can evaluate your models, as well as how you can change your config and get to the advanced users, right? So on and so forth.
Okay, great. Thank you.